Today, I'll be presenting my science project on the Haber process, which is a super important industrial process used to make ammonia, something that affects what we eat every day, even if we don't realize it. The Haber process is the way industries make ammonia from nitrogen and hydrogen gases. It was invented by Fritz Haber in the early 1900s and changed the world. Why? Because ammonia is a key ingredient in fertilizers, which help grow the food we eat. Without this process, farming on a global scale would be nearly impossible. Why is the Haber process so useful? Well, plants need nitrogen to grow, but they can't get it straight from the air. Ammonia makes nitrogen easy to absorb for plants through fertilizers. This helps crops grow faster and healthier. Without it, we wouldn't be able to feed everyone on Earth, especially if you consider the growing rate of the population. Now, here's the actual chemistry behind it. Nitrogen reacts with hydrogen to make ammonia, and the balance equation can be seen on the screen as well. And the double arrow means that the reaction is reversible, so it goes both ways. It reaches a point called dynamic equilibrium, where the forward and reverse actions happen at the same rate. So here's a step-by-step breakdown of the reaction. Nitrogen is taken straight from the air, hydrogen comes from natural gas, also known as methane, and then they're mixed in a 1 to 3 ratio. That's 1 part nitrogen and 3 parts hydrogen. The mix is heated to about 450 degrees Celsius and put under 200 atmospheres of pressure. An iron catalyst helps speed up the reaction. Ammonia is formed, gets cooled down, and collected. Unused gases are recycled to go through the process again. Now, where it happens, it happens in giant industrial reactors. These are tightly controlled environments designed to get the most of the ammonia possible. They use a loop system. Cooling is used to remove ammonia, and any leftover gases are sent back into the reactor to go again, which makes the process a lot faster. Now, the environmental and health concerns. Even though the Haber process helps us grow food, it comes with a big cost. It uses 1% of the world's energy, most of it which is from fossil fuels, which also creates CO2 carbon dioxide emissions, which affect climate change. Then fertilizers can run off into water, causing pollution and dead zones where fish can't survive. This is called eutrophication. High nitrogen levels in drinking water can also cause health problems like blue baby syndrome, which affects infants. Now, the pros versus the cons. The pros are that this process helps feed billions of people, it boosts agriculture, and it keeps plants healthy. But the cons are that it creates carbon dioxide emissions, it pollutes water, and it uses a lot of energy. Now, can we feed the world without it? 50% of the world's food is dependent on the harbor process fertilizers. But the with that is that it uses 1% of the global energy. Now, it doesn't look like a big number, but when it's actually put into perspective, it is using way more than it should be. But it also helps the crop yields grow 3 times faster because of the nitrogen fertilizers, because of the ammonia. Now, the conclusion. To wrap it up, Haber process is one of the most scientific discoveries uh, of the 20th century. It helped us grow more food and support more people, but it also has environmental downsides. That's why scientists today are looking for greener ways to make ammonia. But the real question is, can we keep feeding the world without harming it? Thank you.